Welcome back to the League of Legends Depreciation Appreciation Committee for Destruction and Justice. We are back once again wearing our anti-League memorabilia. So if you see anyone playing League of Legends, you should promptly destroy their computer and ask them to stop it. But great things are upon us today because we have returned for some good LeetCode. We also have the holidays upon us, as well as a great reflection about the time that we have spent working at something difficult. What else can we say than thank you for the suffering? So it doesn't get any better than that. I also have some very, very sad news. The daily game dev must come to an end. This is kind of intimate. The daily game dev must indeed come to an end. I was posting daily game dev videos, but I don't know that it's an actual hit. So I'm thinking what might be a better wave is to just stream it and then cut it into content that would be pretty much become a devlog. So that's what I'm thinking. So I'm thinking I won't record them and post them, but if I'm going to do it, I might as well post it, right? But also it would be cool to have a daily game dev log. But at the same time, I don't think it's hot. I don't think it's hot content, and it's probably better to do something a little more to mix up the content on the channel so that we do have some daily stuff, but at the same time, we have daily progress on the game dev as well, so we can have like a weekly devlog that actually has something valuable in it. So that's what I'm kind of hoping for. But at the same time, it feels like we're giving up. But at the same time, I don't want to just bombard the channel with daily content that isn't exactly interesting. So we should try and do some other stuff to mix it up. So I'm going to try that. And if it doesn't, I'm going to try that for a little bit. But we're still going to go daily. It's just not going to be recorded, unfortunately. Or posted. Where it's going to be posted as one. It's going to be recorded, but posted as one complete video at the end of the week. So I think that is much better. I think that's a much better way to go about it. So that's what I'm thinking. But yeah, I'm thinking that's the wave. And at the same time, we'll also do some streaming. I don't know if we should be able to make it all work, but that would be ideal. So basically, the change that's coming on Monday, we're going to kick off the stream. And I'm just going to have it linked into the Discord somehow. And we're going to do that. We're going to try and do a daily stream every day. That stuff will be cut out into a devlog daily. So, I mean, at the end of the week for a total devlog. So, that's what I'm thinking. And hopefully we can make it all, hopefully we can make it all make sense somehow. But could we actually make could we actually make a stream every day work? Is it something that's possible? I'm not exactly certain. Do we have the juice, the constant juice to stay juiced the whole time? I'm not exactly certain. So, that's what I'm thinking. But it requires, we shall see what it requires. So, there's definitely some things floating about. I'm definitely thinking a weekly game dev blog might be much better than what's been happening. So, that's what we're going to go for. Where the stream's going to play into that, I'm not exactly certain yet. But this will all make sense in retrospective. So that's all that really matters. That being the case, though, we've been given the best gift that one can ever receive, and that's another challenge by the LeetCode developers to not only stomp, but overcome our mental barriers so that we can continue to solve problems. They've created over 2,700 problems to keep us down. We've decided against that so that we can do even more. So, I think we're currently... Where are we? Oh yeah, LeetCode servers have really been struggling recently. Someone's got to say it. But we're about 1/3 complete of all the easies, and I can't wait till we get to the end. I'd really like us to finish all of them before the end of the year. And then by year 2, I mean, it's a wrap. It's a wrap by the end of year 2. End of year 1, it's a wrap. We're just going to be a different breed of programmer. So hopefully we can continue from there. But I'm still going to record today's game dev session. I'm just not going to post it as a video every day. I don't know if that is flames, but so many ideas floating around. Who knows? What I do know though is that we should definitely jump into the LeetCode. So what we do know is that if you're interested in something like this, you should definitely join the hyperbolic coding chamber because the HCC needs you. So I think we're going to do, I don't want to do too little because then it'll be like we changed up, because we have been doing less time recently because of the holidays. But next week we should be able to kick everything into gear, full throttle. I think we're gonna aim for an hour here, maybe an hour of game dev, and then I think we might call it there. But let's do it. Gotta get to work. The problem we're working on was divisor game, and we're realizing a couple of things with this problem. One, the optimality of choice is not as simple as a greedy option. Either that, or the greedy option to take is not immediately clear to us. This problem has a lot of downvotes though, so that means two things. It either means that the problem has a really weird greedy solution that is hard to intuit, or this is actually a medium problem described as an easy problem, and the graph-based idea that I'm thinking about is the ideal solution. So I thought originally it made the most sense to pretty much choose the highest factor of the number, and that would always give you the answer. Not exactly true, because as you go down, there are better choices. For example, we have a test case for 32. And if Alice always chooses the largest factor, she loses. There's an option where she can choose, for example, when Bob chooses 8, she can choose 2 instead. No, she loses there. Wait, how does Alice win at 32? You have to choose a number that's not 0 and not the number itself that modulates the number and still gives you 0. If you have 32, you only have the options below. You can choose 16, right? And let's just say Bob chooses Alice chooses 32. Alice chooses 16. Since he chooses 16, the number that it gets replaced with is 32 minus 16. Right? Bob chooses 8. The number remaining is 8. Alice chooses 4. Right? When we get to this point, Bob chooses 1. Once we get to, there's definitely a thing. Once we get to the position where you can choose 1, it only makes sense to trade back and forth. What's the first place that you can do 1 so that you don't lose? I think I see it, or maybe I don't see it. It seems like the lowest factor, which is 1, you can always use to get modulus a number equaling 0. If that is the case, how can we make this make sense? If you choose the lowest factor, you can choose 1 and you end up with 31. So maybe the solution is that Alice can always win. If she goes first, and assuming we always alternate, she can always win if the number starts at even. But she can't win if the number starts at false. This might be crazy to check, but we can just check if n mod 2 equals 0, then Alice can win. Otherwise, she can't. I guess if that doesn't make sense. How's my output? Oh, I think I have to uncomment the whole thing. I mean, comment out the whole thing. Oh my god. We are beasting right now. Yo, now I see why this has so many dislikes. Oh my god. We spent like 45 minutes on this problem last time, and I was like, I don't know if this is a graph problem because there's like all this modulus stuff. And then we figured out it wasn't the largest factor, it was literally the smallest factor, because you can always choose 1, which ends up being the optimal move. Why is that though? The number becomes odd. I guess the only number, if the number becomes odd, not the only number that would, you can always just choose 11. But I guess the number that it would factor with is also odd, so it doesn't change the outcome. You just make the number smaller. So if you had an odd number like 49, we can factor it with 7, which would give you a modulus of 0. We do 49 minus 7. No, wait, 49 doesn't even go into 7. If you had 47, right, you could modulo it, I think, 7 times 7? No, what am I saying? 49 does go into 7 does go into 49 7 times. So you'd say 49 minus 7, which would give you 2. I have this right, but I also don't know why my solution works. It seems that the optimal move is always... The optimal move seems to always be taking 1. Why though? Oh, because even if the number goes back to even, I think I see it. Even if the number goes back to even, once Alice makes her turn and she takes 1, it ends up odd again. So you always end up having to factor out an odd number, which means if the number is odd, you automatically lose. But if the number starts odd, Alice always has to factor out with an odd number, which gives us an even number. So for example, we have 49, factor out 7, you get 49 minus 7, you get 42. Now Bob has an even number. He works on it, he makes it odd again. Let me see what the head said. Yeah. Oh my god, this is crazy. This is one of those moments. Brain teaser, game theory. Oh, it is definitely a game theory. It is most definitely a game theory question. This reminds me of the little bit that I read on, I think it was like Learn AI or Stability AI about game theory. About optimal patterns and heuristics for choosing moves in games. Yeah, this is one of those moments where you do a problem and I definitely would not have been able to solve this in the past. Even numbers have divisors of both odd and even. Oh my god. I can't believe I got this. This one's going in the Hall of Fame. But we will delete this problem and go back into the foray to acquire more problems to attack. So now we have rectangle overlap, kth largest, most common. I don't know what just happened. Baseball game. Ugly number is impossible. Make this string great and sort array by increasing frequency. So we have rectangle overlap, an axis aligned rectangle. An axis, what does that mean? An axis aligned rectangle. An axis aligned rectangle. Axis aligned rectangle is represented as a list. X sub I, Y sub I, X2, Y2, where X sub I, Y sub I is the coordinate of the bottom left corner. I see their axis aligned, and X2, Y2 is the coordinate of the top right corner. Its top and bottom edges are parallel to the X axis, okay, and its left and are parallel to the Y axis, so it's going straight into the regular rectangle. Two rectangles overlap if the area of their intersection is positive. Two rectangles overlap if the area of their intersection is positive. To be clear, two rectangles that only touch at the corner or edges do not overlap. So I think they're saying we should use less than, not equals here. Given two axis aligned rectangles, rec 1 and rec 2, return true if they overlap, otherwise return false. They're saying the area of the intersection, area of the overlap of two rectangles overlap if the area of their intersection is positive. First, we need to generate the area of their intersection. Given two rectangles, the area, I'm pretty sure, is length times width. A equals L times W, question mark. A equals L times W. A equals L times W. Well, we need to know that they intersect. For them to intersect, given the top right x coordinate of the right rectangle, the second rectangle's x coordinate must be less than. Otherwise, they don't intersect at all. There's no intersection that can exist with the second rectangle. What if the second rectangle is further left than the other rectangle? I was gonna say the first thing we should check is that there's an overlap at all. Maybe that's not possible. I think what we first need to do is get the far left rectangle first, so that we can order them, and then we'll know if there's an intersection based on how we deal with them afterwards. I was assuming valid input, I'm pretty sure. Rec1.length is always equal to 4. Oh, right. Okay, so x1, right? x1, y1. I have the 2 points. So the far left rectangle is whether or not rec 1 sub 0 is less than rec 2 sub 0. If that's true, then rec 1 sub 0, or we'll set this equal to rec 1, set this equal to rec 2. We'll say leftmost rect, and we'll have rightmost rect. If leftmost rect is rec 1, right, then the rightmost rect must be rec 2, otherwise must be rec 1. Right, now given these true statements, could be that they're the same. Oh yeah, there's no overlap here at all. So for this third example, we should be able to break down at least one case with left right. If rightmost rect's leftmost point, which would be x sub 0, is greater than leftmost rect's rightmost point, which would be index sub 0, 1, 2, right, then we should return false. Otherwise, we should return true. And we should fail all these cases, except for example 3. Which looks good. Then here we know we have some overlap. Actually, we don't know actually. Because it might be too high. So the other thing we need to check is if the topmost point of the rightmost rect is greater, right? So topmost point, that would be second coordinate, so 3 is greater than leftmost rect sub 3, which would be the x coordinate for the highest point on both, then we definitely want to return false. This means that there's no overlap. Is there a case in which, right, this is the only case there overlap, it wouldn't be touching. The other thing is, now something else is at play. Something else is at play here. What else indeed could be at play? How to tell that there's actually an overlap? We'd basically need I think they're telling us we basically need the leftmost and the rightmost edge for the overlap. How would you get the leftmost edge? If we imagine overlap, it would have to be the right. It would be the leftmost rectangle's rightmost point subtracted by L would equal the leftmost rect's rightmost point 0, 1, 2 minus rightmost rect's leftmost point, which would be its x. That would give you the length of the rectangle. And then the width would be how would you get the width? I mean, how would you get the height? I'm pretty sure it's not length times width. It's just base times height or something like that. We have the height. You'd have to multiply. Feels like you need to know what the topmost rectangle is, and then from there you could subtract the height of the topmost rectangle by the lowermost rectangle. You'd get a difference, and then you could subtract the difference from the topmost rectangle. Topmost rect would be the one that's the tallest. So that'd be if rect sub 3 is greater than rect 2 sub 3, then the topmost rect is rect 1. Otherwise it's rect 2. And we'll say topmost rect equals rect 1. then rec 2 must equals rec 1, then bottommost rec must be rec 1. Now that we have that, once diff would be equal to topmost rec sub 3 minus bottommost rec sub 3, which is equal to diff if diff equals 0, then the height of it would equal top most rec sub 3. Otherwise, it should equal, I want to say top most rec, because let's just say the rectangle is it's three tall, and the other one starts at a y of 1. Topmost point would be this one's one you definitely need to draw. You have two cubes. You could have two cubes like this. There would be a grounding required to make sure that the actual subtraction makes sense. The grounding would have to be done by the bottommost point of the topmost rec. It would be the difference between that point's y value and 0. Grounding would be equal to topmost rec sub 1, topmost rec sub 1, topmost rec sub 1 minus 0. I should say 0, math absolute value of 0 minus topmost rec. And to ground it, I would have to subtract grounding from the answer when I do topmost rec sub 3 minus bottommost rec sub 3. and then the return L times W is greater than 0. Oh, I really thought we were onto something. $113. Wait, this doesn't make any sense. It should just be the lowest point. It should be the highest point in the bottom, the topmost rect, subtracted by. Yeah, the lowest point in the topmost rect subtracted by the highest point in the bottommost rect, and that should give you the height. feels like it should be the bottommost Rex highest point subtracted by the topmost Rex bottom point. And I don't know if the grounding thing is required. But if their height is the same, if their height is the same, we won't need this diff portion, because the topmost Rex bottom part, the 0 subtracted by the bottommost Rex top part, should give you the same height. Passing more cases, and I feel like the reason we're not passing the final one, I returned true, they expected false. Pretty sure we can remove this, remove diff, and we can remove the grounding. But the way we get the length should be the same. The far rightmost rectangle's leftmost portion subtracted by the leftmost rectangle's far right portion. So leftmost rectangles 0, 1, 2, far right portion subtracted by the rightmost Rex leftmost. Wait, we're already doing that. Leftmost Rex far right X value subtracted by rightmost Rex leftmost value should give us what are we missing? I think L and W is confusing. I'm pretty sure it's base times height, bro. Base times height. Base times height type B. B is less than 0 or H is less than 0. Turn false. Nice. Yeah, it really seems like we're pretty much trying to get the overlap. To get the overlap, you need to know which one is the furthest right. So you can do the furthest right's left. I mean the leftmost rectangle's rightmost point subtracted by the rightmost rectangle's left point to get that distance. And you can do the same for the height as well. If the rectangles do not overlap, then rec 1 must either be higher, lower, to the left, or to the right of rec 2. Answer for whether they don't overlap is left or right or up or down, or is logical, or in left is a boolean that represents whether rec 1 is to the left of rec 2. Oh, there's an official. Wait, this is the official I was reading. Say the area of the intersection is width times height, where width is the intersection of the rectangles projected onto the x-axis. Height is the same. Width is positive when the smaller. The minimum of the largest rectangle. What we did is just make sure that the area of the overlap is actually positive. That was an interesting problem. I can't say that I entirely understand the way that they solved it, but we were able to get a solution that also works in constant time as well, albeit with more code. So I think we'll take that. This one has a crazy number of dislikes. Given a string paragraph and a string array of the banned words, return the most frequent word that is not banned. It is guaranteed that at least one word that is not banned. There is at least one word that is not banned, and that answer is unique. So if we have a string paragraph and a string of the array of the words that are banned, I guess it depends on the casing. Words in paragraph are case insensitive and the answer should be returned in lowercase. Seems like we can just load this whole thing into a map. We'll take the paragraph. We'll go to lowercase, split it by space. And then I think you also have to filter out punctuation and filter out any non-alphanumeric characters. Paragraph to lowercase, split by space, filter out non. I think we can do cleaned para equals paragraph to lowercase split by space map word. Okay, the function called extract alphanumeric. We'll take a string s and return a string s. We're just going to take this string, we're going to run a match function, and we're pretty much going to grab everything from A to Z. I'm going to print cleaned para and return an empty string for now to test real quick. Maybe it's 1. Now we're just getting the second letter. I just wanted the letter itself. If we just duplicate this and I do console.log s.match or an empty string. Oops, I forgot to. getting an array of all my matches. I kind of wanted them all together. It probably is because I'm using a single character class. If I did something more like this, I said star. I'm going to put it up here to test. Right, then we get Bob hit a ball far, and we shouldn't get anything like the punctuation, or we shouldn't see anything with hit for the last word. And then we can return. And then we can create a map. String to number. We'll say const value is equal to map.has word, right? If it does, we're going to get the occurrences for that word. Otherwise, we're going to set it to 0. Say map set word to value plus equal 1. After that, we can spread the map right into an array, which will give us an array of tuples that will then sort based on occurrences, but they want the word, the most frequent word, the most frequent word that is not banned, which means I'll change this to T1, so we'll do it in descending order. And then we can return R sub 0. You probably have to break this up like this. Yeah, this one wasn't too bad. I'm wondering why it had such big dislikes, but this should be, I think it should be like O of S, where S is the number of characters within the entire paragraph, and then we have to sort them. Should be O of S plus S log S to sort the, oh no, O of S, where S is the number of characters in the string, and then O n log n, where n is the number of words in the paragraph. Sorted with constant space if we're guaranteed only lowercase English letters in the map, but the clean paragraph is linear space. So this looks like I guess you could do it in linear time if you just iterated through and then ignored characters. And I think you could also do it with, would it be possible with, there's no way. How would you know? Oh yeah, then you could just go through your count array. Well, I guess no, that's not factually fair, because then we could do the same thing here. Instead of sorting, what we could actually do is just say max word is equal to an empty string, and then we can say max awk would be equal to 0, and we'll say if value plus 1 is greater than max awk, then we'll let max word equals word max awk equals value plus 1. That way we can skip the sort, and we can just return max word. That is a good point. Sometimes I forget that you don't have to sort. It's just easier to sort rather than when you're looking for a max or min, you can just get it in linear time. I think I'm satisfied with that, so we'll stop there.